Well, we did a master class on study designs on a podcast by Kaho. So we received some important questions, a few of them, and we promised to reply to them. So some of the replies are in this video because we understand that we are trying to demonstrate techniques and we can't make a lot of content on one video because it will become difficult to retain and use later. So alpam, alpam, muhar, muham, that is what the Vedas say. Thoda, thoda, kai, kai bar. Thank you. The knowing will come by repeatedly seeing that YouTube, then seeing the segments of it which apply to your research protocol, then using it and then teaching it to somebody. So don't worry, all these technical terms with usage will become easy क्योंकि करत करत अभ्यास ते जड़मत होत सुजान रसरी आवत जाते सिल पर परत निशान। पहली बार सुनने में कोई इतना होशियार नहीं है जो कि ये सब का सब समझ गया हो। Now this question is about the regression. What is the regression calculation? I would advise the person who has asked it to see the YouTube 2 or 3 times or 4 times till he understand it. But in short, the regression is trying to correlate the cause to effect, keeping the confounders constant. So effect is on the left side of the model, exposure plus minus, confounder 1 plus minus, confounder 2. So here the relation would come between exposure and effect, keeping confounder 1 and confounder 2 constant. But let us say if the effect is numeric, then there will be linear regression. If the effect is yes, no, like heart attack, yes or no in the next 10 years, then the model used will be logistic regression. And when the effect is time distribution, like heart attack will occur in the first year, second year, what is the probability of the heart attack occurring in the first year, in the second year, in the third year, in the fourth year, then the method of analysis is called as Cox proportionate hazard model. If you are only relating treatment AB to effect, then it is Kaplan Mier survival curve. So this is the basic type of analysis that is needed in these various situations. Well, let me introduce you to how to let me introduce you to how to compare two patients being treated for cancer and how much time they survived. So here the effect is time distribution. When did they die, or there was recurrence, or there was metastasis? So these important events have a time distribution. When they occurred becomes important. So for such, the data recorded is shown here as time distribution. So we'll show you this Excel sheet. So here is the treatment group 1 or treatment group 2. In this shows that the event has occurred, and the missing means that the event has not occurred. then in those that the event has occurred at this many months, and we do not know. Censored means we have not been able to follow up this case. So we do not know in this case that whether the event occurred or did not occur. But in this case, we know that the event has not occurred. So this is not lost to follow up, and this case is where the event has not occurred. We know that. So there is a censored variable which charts that there is loss to follow up, and here is confounder 1 and confounder number confounder 2. But just now we are just trying to compare the treatment group and compare this and find out what was the survival. That means event occurred means died or recurred or metastasized. So we are just trying to find out which of these two groups the adverse event occurred later. So that's the time distribution, and we are comparing these two groups, and I hope you have understood how to make this Excel file. Now after that, we close this and we launch the EpiInfo. We launch the classic. We say read, and we say that our database is of XLS type. Then we say that we browse, try to find out where is that data set. It was on the desktop, so we say test, and we click this time distribution XLS. We open it. We say first row contains header information. We say sheet 1. We say OK. And here our data set is open. We go on to Kaplan Mier survival. We say that the censored variable is whether the event has occurred or not occurred. So here is it occurred. And then we say that the time variable, it occurred when. So here this is occurred at, and the test group variable where we are trying to compare the two is the group, the treatment group the patient belonged to. And we say that the value for the censored uncensored is that the event has occurred is 1. Okay. And then we say that this graph type is survival probability, and we try to say okay. So here is the graph. It shows two curves. This is group 1 and this is group 2. And obviously you see that group 0 is surviving much more than group 2. Is surviving much more. And this is the probability chart. So at this point the survival is between 0.85 and 0.9. At this point it is 0.75 to 0.8. But this fellow is just surviving. So the difference between these two graphs shows that the blue is better. And all of the group 1 died between 22 and 23 months, 22 and 24 months. But this fellow was surviving for 34 months, the blue one. The group 0 was surviving for 34 months. How many were surviving for beyond 34 months? Survival probability was between 0.3 to 0.35. Okay, so these are the two curves, and this is the statistics, and the difference by both statistics, log rank test and Wilcoxon test, is significant at p.05 levels. So this is the Kaplan Mier statistics trying to compare the two groups, exposed and unexposed, or exposed to treatment A or treatment B. Well, this much is enough for this video. We must learn little many times. Alpam alpam, muhar muha. So we'll learn confounding control by linear regression, by logistic regression, and by Cox proportionate hazard model next.